Hello, I'm Wayne Yateman, and this is an overview of my concept and designs for a prototype 24 kilowatt self-powering generator, which is designed to be as simple and inexpensive as possible to build and test. This particular design version and concept is called the Electromagnetic Differential Drive Generator, abbreviated to EDG version 4 or DiffGen. The bench top is 1 meter by 2 meters, and there is a CD on the bench for visual scale so you can see its size. The idea is to spin the axles of 2 standard 12 kilowatt alternator generators to produce electricity. Each generator has a drive wheel which pull each other around using electromagnets which turn on and off in a timed sequence. When each generator spins at 1500 RPM, it produces 12 kilowatts of electricity, so together the two generators produce 24 kilowatts. The electromagnets which power the drive wheels use 24 volts, so since the output of the generator far exceeds what is required to run it, it's able to power itself with plenty left over to power other things. I'll break it down to explain how it's put together and how it works. I started with 2 of these standard alternator generators. Each generator head has a specially designed drive wheel attached to its axle. One wheel is the active wheel, which contains electromagnets and reed switches that switch the electromagnets on and off in sequence. The other wheel is the passive wheel, which contains magnet contacts and small switch magnets to activate the reed switches. The active side also has a simple commutator or rotating connector on the generator and axle to transfer power to the spinning drive wheel containing the switches and electromagnets. These 2 generator and drive assemblies are mounted on a frame facing towards each other. The frame has an arch with 3 small wheels which fit between the 2 main drive wheels. I call these the differential wheels. Here's just the frame and active generator so you can see the differential wheels. There are cooling fans attached to the axles of the differential wheels which spin when the differential wheels spin to provide cooling. The 3 small differential wheels act like a differential gear to keep the 2 generator drive wheels rotating opposite each other evenly and to keep an even distance between them. The 2 main drive wheels don't actually touch each other, as you can see in this cross section. Now let's take a quick look at the wiring and controls assembly. A heavy-duty 24 volt battery powers the active wheel via a simple control box through the rotating connector on the active generator. Once running, the generator can be powered from the electricity it's producing and charge its starter battery with a standard charger. There are 2 standard laser temperature probes and 2 standard laser RPM meters, one for monitoring each drive wheel. The control box has drive speed controls. Increasing or decreasing the voltage supplied to the electromagnets will effectively increase or decrease the drive RPM speed, which is determined by how much magnetic attraction the electromagnets are producing. Here's the components of the controls assembly. Now let's take a look at how the main drive section works. The active and passive drive wheels each have 2 sections. A main drive magnet section towards the outside of the wheel. This is the 6 electromagnets on the active wheel and the 4 magnet contacts on the passive wheel. And secondly, a smaller switching section towards the inside of the wheel. This is the 3 reed switches on the active wheel and the 8 switch magnets on the passive wheel. The reed switches and switch natural magnets in the switching section are shielded from the magnetic fields of the main electromagnets and contacts with EM shielding foil. The main drive wheels themselves and other parts are made of a durable material which is relatively unaffected by magnetic fields, such as silicon nitride ceramic, so they don't affect the functioning of the drive. In this switching sequence animation, you can see how both main drive wheels interact to make the drive spin. The active wheel, which rotates clockwise when viewed from this side, has the electromagnets, which are the 6 red circles, and the reed switches, which are the 3 orange rectangles. The passive wheel, which rotates counterclockwise, has the passive wheel magnet contacts, which are the 4 green circles, and the switch magnets, which are the 8 smaller blue circles. When the drive is in motion, the reed switches on the active wheel activate the electromagnets on the active wheel. When a reed switch is activated by the close proximity of the switch magnets, a pair of electromagnets on opposite sides of the active wheel turn on and pull towards the nearest magnet contacts on the passive drive wheel, then turn off again when passing by. The close proximity of the electromagnets on the active wheel to the contacts on the passive wheel cause powerful magnetic attraction. The distance of these magnets and contacts from the center of the wheel provide leverage, and the spinning motion works like a flywheel for momentum and balance. Right, that's the basic overview of how the drive works and how it's put together.